Dooby 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 doo. Dooby 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 doo. Dooby 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 doo. Hey, we've got sound. And music. Hey, do you like the music? It's good, I do it myself, you know. Ah, lovely, lovely, lovely. We seem to have a system going. Yeah. We have a stream. We have a system going. Rust Game Dev Studio. Oh, OpenGL. Ooh. Ooh, heck. Yeah. We've been messing around with the Windows 32 API. And we got it working. Yikes. So my goal on these streams has been to show that you can, from scratch, do anything you like with Rust. Yeah. The programming language, Rust. Wow. You can do anything. You don't need all of these cargo crates and libraries and things. No, not really. But I've been striving to make things simple. Yeah. And so far I've succeeded, I believe, in producing pretty simple code. We have a window. Very simple code. Just creates a window, constructs the window class. I've piled in a load of error checks, which just confuses the matter. But the actual code for loading the window, very simple. Very simple. We'll be coming back to win class EXW very, very yeah, very soon. Yeah, we're going to need that. And yeah, there's not really a lot to it. 154 lines of code, and a lot of that is spaces. Right, so yeah, the code, very, very simplistic. Not much to it. So I'm quite happy with that. Alright, I'm going to be using Triangle from Scratch, loading OpenGL, which is here, Triangle from Scratch, loading OpenGL with Win32. Why? Because it's the only resource online that I've found that actually talks sense. Yeah. So we do have the Microsoft Win32 OpenGL rendering context thingy here, which just takes you through to rendering context on the Microsoft Graphics and Gaming OpenGL. And it's good stuff to read. Good stuff to read. And of course the OpenGL wiki, which is, there you go, simple context creation, how to do it, and all the rest of the stuff. And then, yeah, create a false context. Yeah, about that. And it goes through it all. What we have to do. And of course it's got the references at the bottom to the WGL, which is going back to the MSDN. WGL is the prefix for Windows graphics library. So the OpenGL Windows graphics library. Okay. So it's good reference material, and it's all at the opening here on the documentation for Triangle from Scratch on loading OpenGL. There you go. It's all the reference you should need to be able to do it. So that loading a false context business, what's that all about? Well, The Windows 32 API has a little problem. They didn't design it for OpenGL, did they? They designed it for DirectX. And OpenGL needs to know what the window comprises of. How many bits it can use for the colours, for instance, and things like that. So we're going to see that. But the Windows 32 API only allows you to set that once per window. So of course, we have to get a context for our OpenGL, setting it up with a default window specification. And then if we want to extend, say, into version 3.3 or whatever you're going to be using in OpenGL, whichever version you want to use, those are all extensions which you have to then load up after you've got your first context. You have to use your first context to load up your extension. And at that point you need to change your Windows specifications to use that extension. And you can't do that with the Windows 32 API. So you have to create a false window, load up your extension, destroy your false window, and create the window you want to use. But I want to look at that false window. I want to look at the context it creates there. Because if I'm right, that's OpenGL 1.1. Which is the unextended version of OpenGL, which should work fine, theoretically. Okay. That would simplify things if you didn't have to destroy things. And you could use OpenGL 1.1. Okay. So, cleaned up Windows 32 example. Now, by cleaned up, this person means they've put strange things in there. That's fine. So what we need is a device context. And to do that, we're going to have to tell the Windows API, this line here, it's going to be CS underscore own DC. In other words, we want to use our own device context. And I'll show you why. Put that up for a reason. So if we go to our project, Rust project, we go to the OpenGL, target, debug. I built it already. So this is what I'm using, dev win32 OpenGL. It's just a copy of our dev win32 API. It's literally a straight copy. I did cargo new, dev win32 OpenGL, and then I just copied the source folder over from our last project. Alright, can we get rid of the utilization, please? I'm just waiting for this to settle, see if it does, and I don't know why it's using my Windows. What are you doing, computer? We're streaming. Right. That messes it up. So this here, 34 degrees C, okay, from the stream. Here's our program that we've done. It's not using anything. So that device context is for what? Yeah, it's for our GPU. As you can see, this program is not using our GPU. Nothing's happening here. He uses a little bit of memory, but hey-ho. And we need access to the GPU. And that's what OpenGL does. Gives you access to your GPU. So you can program it and do graphics. That'd be nice. So this Win class W. Construct the window class. Here we go. It's here. We're using EXW. But there's your styles. I've already noted that I want these two. But we don't have any of these CS's. Or we shouldn't have. So if we have a look in our types for the Win32 API, no CS's. I've got a CW. Oh, I did change it over to colour background 1. Oh, good. Alright, that's fine then. So we're going to need a couple of public constants, aren't we? So if we're looking at this, it tells us that we can look it up to the window class styles page. And there's lots and lots to look at. But the notable ones are, and he's pointing it out here, are the horizontal redraw and vertical redraw, which, yeah, okay, we'll use. And nicely, he's put them in here. Okay, so I want you first. So I'm going to take you. And we're just going to pop you in here. So I want the H redraw, horizontal redraw. I'll do that one next. Not going to be putting them in order. I'm doing this alphabetically. We'll take that one. He hasn't put the full numbers in. Okay. Doesn't matter. And we'll need V redraw, won't we? So those are the three that we're going to need. I don't like the way he's done that with 4 numbers instead of the full 8. So I'll change it. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Whoa, that was too many. There we go. Yep, works nicely. Okay, so we've now got these 3 CS's. And what they are flags. So as you can see, it's the first position, the second position, 20. What's 20? Value of literal is 32. Which is the fourth position, is it? 1, 2, 4, 8, 16, 32. No, it's that position there. So they've got 2 zeros as well. That's fair enough. So it's this position. If you put it into zeros and ones, that's what flags are. They're just zero. It's just a long line of zeros and ones which you can OR together, which basically flips the bits into one chain of zeros and ones, which you can use in a Boolean operation to say, are they switched on or off? And if they are, you can do different operations depending on which flag is set and which one isn't. That's how flags work. They're a nice, easy way of doing things. So what we're going to be doing is this, really, I guess. Better put a comma at the end. I'm just going to OR that with, doesn't matter which order you put them in, CS underscore own. There we go. So we're changing our Windows class extended version wide, which tells Windows 32 API, hey, we want you to operate this window with these flags set. Which means every time there's a paint, we want you to do a horizontal redraw and a vertical redraw. So when you drag in a window around, like this, you can see it's redrawing. Yeah? So that's what those two flags do. And the own DC means that we want to use our own device context, which we're going to put in OpenGL. So we'll set those up. You don't need these two, but they might be nice to have. Not quite sure. And now we need this, the pixel format descriptor, which tells the window how the pixels in that window are to be treated, or how we want them to be treated. And this is all part of setting up the window so that we can do this. So we need to fill one of these out. So this is our request for what we want the eventual pixel format of the window to be. And this is the thing that stops us from loading up. This can only be set once. Yeah. So it goes down. Yeah, it's in C. Yeah, I know that. Windows 10. Yeah, okay. Yeah, it's talking about cargo, blah, blah, blah. So, in terms, okay, so, oh, look at that. So this gives a nice long list of the structure for pixel format descriptor. And it's a biggie. Now, we know what to do with that, because we have structs. We have them in here. This is why I separated everything off. Now, he's not going to be using an unsafe implementation on this, I don't think. No, we won't be using an unsafe implementation default to 0, correct. But we will be using this lot. I would like to change it though, because he's done it differently. Okay. Alrighty, I think we've got bytes and words, haven't we? Yeah, we have. Yeah, I've already got everything in that we need there. And of course it's complaining at me. So I do need to change all of these. Alright, that's fine. So that's n size. N version. So size. Pixel format descriptor. Size. That's the size of the structure that we're using, I believe, because it's the first thing in it. That would make sense. The version, not too sure. Some flags. We've got an integer of pixel types. So you can see what I'm doing. I'm just putting it into Rust. A C color bits. C. They're all C. Red bits, redshift, green bits, green. Yeah, okay. I see what you're doing. Yeah, I'm definitely going to do this. I don't like upsetting Rust for no reason whatsoever when you can just do this. I mean, there's no harm in it. Oops. Take you out. Because it doesn't actually matter what we call them. To be honest, you can call them anything you want. This is our code, not Windows. As long as it matches what Windows does, it's fine. What we call them is for our reference, not for anybody else's. We'll type that into a small s, please. Blue bits, okay. Da 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 dee dee. I like this kind of programming. This kind of programming is nice and easy. Blue shift. Oh, alpha. So we're doing RGB. So we do have alpha, which is opaqueness, I suppose. How much you can see through something. Okay. So you can see through windows. That'd be nice. So we'll have some alpha bits. Okay. What else we got here? A cum. I don't know what these are. I'll have to look that one up. Again, I'm trying to keep this all as simple as possible, and then you get this really massive thing here. Which is typical. But once it's done, it's done. Gets used once at the very beginning of your program. It doesn't get repeated. Red bits. Oh god, this is getting worse. So, bits in total, then you got your red bits, your green bits, your blue bits, and your... Yeah, okay. Fine. I mean, it's your choice whether you want to do this or not. I do, because it cleans everything up. And I prefer clean code. So ACCUM means accumulator to me, but that's possibly not what it means. Oh well. But I do want to use it, so... Alphabets. I like that idea. We might play with that later. Depth. Now, this is the important one. What depth are we going to be using? Usually it's 24-bit, isn't it? Usually. For the depth buffer and things. Delete. Depth. That's if it is a depth buffer. Stencil. Stencil buffer. Yeah. That's very useful. That's usually 24-bit as well. Usually. But it's whatever we set it to. We've got some auxiliary buffers. Oh, interesting. Not sure what they do yet. Then we've got the integer layer type. Okay. So I've got some kind of layers going on. We've got something that's reserved. Fair enough. Why not? We've got the layer mask. Ah, so that's for masking the layers. Alright. Okay. So there is masking as well. All useful stuff for graphics. Visible mask, yeah, of course. Makes sense. If you're going to be using up that kind of thing. Damage mask. What then? Earth? Okay. Damage mask. No, nothing comes to mind. What a shame. But there we are. We've now got a pixel format descriptor that works in Rust properly. Not sure why he didn't convert it. Weird. We'll have to use a default implementation that is mostly zeroed memory and also set the size and version for us. Got you. Alright, so we're going to be implementing a default on this ourselves. That's fine. Inline, must use. Okay. So this is a default function. Instead of using our default zeroed, which would just zero all of this out, because it needs this size and version thingy at the top, which has to be filled in. Yeah, n version equals 1, and the size is the memory size. Yeah, as a word. Yeah. Out. Okay. That makes sense. So we do need that. There we go. So out.nsize doesn't exist because we changed the names. Oh. There we go. N size is that. N version is that. There we go. And that should make that happy. So all it's doing is it's taking itself and it's zeroing out the memory. Then we're setting the size to the size of the structure, which is the memory, how much memory it uses. And then we're setting the version to 1. So that we're getting version 1 of the pixel format descriptor, or the pixel formats, which is what we want. We can't set it to like version 3.3 or whatever, because we're not loading that for OpenGL. We'll be loading version 1. Oh dear. Well, that's made that bit easy, but we've got this horribly massive structure. Filling out our pixel format descriptor. Here we go. Right, so we have pixel format descriptor, draw to window. Oh my god, we've got all of this stuff. Do you give us the values for these? You do. Here we go. Support OpenGL is 20. Draw to window is 4. Alright, you got them here as well. Oh my god, there's lots of them. Alright. So this gives us everything that we're probably going to need. Are those duplicated? Draw to window, support OpenGL. Draw to window, support OpenGL. Yes, they are duplicated. Alright, these are all held in wingdi.h in C. So that's where these have come from. Okay, and it looks like the hash defines. Lovely. I'm not sure about this bit here. Anything else that's a bit weird here? Okay, we've got depth don't care, double buffer don't care, stereo don't care. Stereo, I'll guess, is for doing like virtual reality where you've got two screens or something. Anything else in here that's... yeah. Needs system palette. Okay. Generic accelerated, support direct draw. Direct 3D accelerated. Oh, I see. That's where you get direct 3D from. Ah. Alright, we're going to take them. Probably going to need these. I don't think we're going to be using them all. Somehow. We'll see. We will see. We need to put these into our types. So PFD goes in here. So I'm just going to pop them in. And just remove these. As I don't want them. And these should now highlight. Yeah, there you go. They're not being used. Right, so we're going to find out exactly what's being used here and what isn't in a second or two. Alright. Right, so where are we putting this? Okay. This is going to go after the wind class or before. Right. Okay. Right. So it's looking as though we're going to be putting this somewhere. Right, it's an external call to the GDI32 library. Okay, so there is a library involved. GDI, we've only got kernel 32 and user 32. Okay. I think we can pop it in here. Can't see why not. So we'll do that. I'm going to keep the note in. Never know, that might come in useful because I can click on it, control click on it to link it through on here. So it's choose pixel format. We've got HDC, which is our the handle for the device context. A PPFD, which is a pointer to whatever we construct for that structure. And it's going to return to us a cint. Not a bool. So I'm going to click on it. Find out what that return type is. Not used, not used, not used. Oh God. Return value. If the function succeeds, the return value is a pixel format index. 1 based. That is the closest match to the given pixel format descriptor. So whatever we ask for from the Windows 32 API, it's going to give us back something. But it fails on 0. That's okay, we can check for 0. So as usual, it's quite straightforward, and there's some remarks here. Yeah, 24-bit RGB colour. Yes, it's just going to give us like either 24 or 8 back. And then it's got example code here. So yeah, it's just all zeros, most of it. They're using Window OpenGL double buffer type RGBA. Yeah, which makes sense. 24-bit, as expected. 32-bit Z buffer. So that's what that is. Oh. Alright. That's the reserved buffer, isn't it? Yeah. Main plane, main layer, yeah. That's the reserved. Layer masks ignored. Okay. And then it just sets that up. Yeah, yeah, yeah. Makes absolute sense. Requirements. GDI32 library. which we're going to be using because we've just put it in. Alright. We just now need to find out where we set all of this up. So let's check. Yeah, I've just checked the docs. Thanks. You're allowed to pass a null pointer for the pixel format descriptor, so we can just require a reference instead of requiring a const pointer. Ah. I'm not sure I want to do that. It's where we're placing it that is worrying me. I think it goes before. That would make sense. We don't have HDC. Yeah, I know. Huh. All right. Interestingly, it's not really telling us where to place this. I understand that bit. And this is what I want. So we have to set this up and then we call the pixel. So where are we getting our HDC from? Here. I see the problem. So our handle to the instance, key pressed. We'll just get you out of the way a minute. Get the module handle. Icons, class name. Could not get the instance handle yet. There's our H instance. Handle instance, yeah. Atom, yeah. That creates, register the window behavior with the operating system, yeah. And that's just creating the window there. That's what you do at the end. Lovely. HDC, why does this... I'm actually using the handle to the window, okay. Ooh, why is this bothering me? Because that's the instance of the window, isn't it? Is that... That's not necessarily a device context. We're only calling the device context in... the event system, aren't we? Is that true? I don't even think we're calling it here. Oh, okay. Fine. Where is this going? Okay. For some reason, this sort of like goes through everything about this pixel format descriptor, but it's not really telling us where it's going. Yeah, we can choose the pixel format. Yeah. But it's not actually telling us where. Well, that's interesting. Get DC and release DC. So I'm going to need to use the 32 for that. So we're going to have to get a device context and then release a device context, but we don't need to release it at this point. We need to release it on shutdown. The program shutdown or the window shutdown. That's when you destroy a window. Okay. I can do that. Libs, please. So it's under user 32. So we are going to need U2. Windows, why have you just... got rid of that? I do want to get rid of the triples. We go down to 2s. Okay. Alright. So we've got get DC and release DC. And that does take the handle to the window. Okay, well, I think we've got that. And here's the warning from the wiki, the OpenGL wiki. So he's actually put it up. So Windows does not allow the user to change the pixel format of a window. Yes, we know that. So you're looking at making a fake window. Right, so what we're doing is we are registering the class. Alright, this gives me more information. Very difficult to follow sometimes, this. So they're looking at making a fake window, I'm not. So we register the window class here. Logging an error in case. So they're putting it here. So there's my slot. How do I want to do it? do I just want to put the code straight in here, or do I want to create an extra bit? I don't think I want to call it fake window. Oh my god, look at all this rubbish. Real Windows stuff. Alright, this is where we're going to be deviating away from whatever they're doing. So I do need this bit. That's going to go in there. So DW, let's have a look. Yeah, I'm okay with that. Yeah, I'm alright with that, I'm alright with that. iPixel type. We've just got to change the names, that's all. There we go. It's not hard to do. And that will allow depth bits 24, color bits 32. So yeah, we're using 32-bit color. Yeah, I agree with that. There's 4 colors times 8. 32, yes. Okay. There's RGBA, is what I'm trying to say. The depth buffer is 24 bits, okay. The stencil is only 8. I didn't realise that. That's perfectly fine. So I'll pop that in. And the layer type PDF, yeah, main, okay. I'll take a bit of tidying up all of this stuff, but... And that's your default. So that's my version of it. Okay. He's now creating the app window. So this is in the wrong place. All right. So we're creating the window here. With height title, yeah. Where are you setting this? Okay. So there's you get DC, yeah. Choose a pixel format. You're doing it after create app window. Okay. So this is where it gets confusing as hell, because there's a fake window involved. If you're not confused by now, you should be. He's put it here. And I don't see why you would. Because PFD isn't used until here. Which is after this create window. I'm getting a little bit suspicious. I understand what's trying to be done, but it's the order in which you do things. That's what programming is about. If we get the wrong order, obviously, it doesn't do it. So create app window. He's got his sample window, class, a fake window, a non, a 1-1, and a null mute. What's the 1-1? That's interesting. Might have to come back to that. You see, this is why you don't use magic numbers. 1,1. Yeah, right. Okay. Doesn't mean anything to me. Neither does non, the null mute. I don't see what these are. Doesn't make the code very readable, does it? I'm gonna have to place this after this, because we're not setting it until here. To me, this doesn't make sense. Does this make sense to anybody else? There's the clue. Right. So we're now stuck on pixel format descriptor. Well, we're not stuck. I know the solution, but I'm not liking it. And I don't want to do those asserts. I know why he's doing them, but I don't want to do a fake window. I want to do a final window at this stage. So I need to do this slightly differently to what he's done. Okay. I don't think I want this here. I'm going to go back to here. Back to the construction of the window itself. Which puts me here. So if I just pop you over that. I don't like it being there. But that's beside the point. We can move it later. So this would be the start of OpenGL context creation. I'm going to put this in as a note to myself. I've got a feeling that that's right. All right. Yeah, these two lines of code will look awful. We might have to, well, we will have to alter them. So those are the 2 lines of code you've given us. So our H wind is the handle to the window, which is here. HDC is the get DC here. Yeah, that's that. And this we haven't written. Create app window, yeah, so it's this one. Finally, we get a use for that. You go in there. Right, that's cleaned that up. I don't want the word fake in there at the moment, so we'll get rid of that. I don't want an unwrap. That's okay. Choose pixel format. Alright, so we need to write a choose pixel format function. That makes sense. Did I say that I'm trying to keep this as simple as possible? And you can see from the left-hand side how non-simple it can become. To the point where I can't even read the code. But we're going to try this and see if it'll do anything. You never know. Do we have a shutdown? We might have to write a shutdown for this. Awkward. Very awkward. I guess we'll find that out later. What I don't understand is why he's gone for a box on the new real Windows stuff. Not my problem. Not yet, anyway. Alright, let's see what you're doing there. That's a straightforward return value. That's okay. We should be checking something here. Yeah, if we've got a null. Probably need an error check on this. Okay. Right, so this is his code for the choose pixel format. Okay. Is it part of... Hold on a minute, where does this come in here? Right, I've got the implementation. Okay. I've got to be careful where I put this. Okay. Create window, yeah. Update client area, yeah. Return the window to the handle user, yeah. Here. It goes here. So it's a public, yikes, unsafe. Don't like this. Function. Choose. Pixel format. And then we've got all of this stuff, haven't we? Yeah. So we're going to have device context handle. Yeah. That's just going to be a HDC. PPFD, pixel format descriptor. And that's just going to be a reference to the pixel format descriptor. And you're giving back a result with a win error. Okay. Which I don't want to do either. We'll give a result, but I'm only going to pass you back the cint. I don't want the error. I'll deal with the error if I need to. Later. I'll look through this for error checking. So basically it's just return the value from choose pixel format. Yeah. That one. That's all I need. It doesn't like something. The cint. Okay. Why can't I not return you? Cannot find cint in this scope. Import cint. Standard FFI cint. Yes, please. Okay, that's you done. So that's the simplest interpretation of what they've put here. Okay. That satisfies everything in these two lines except this isn't used. Unused variable, PF index, I know. What are we using that for? What do we want a PF index for? We want it because we need to know what it is. But what are we going to actually use it for? It's here. Interesting, really, how this has been put together. Okay, we've done that. We've got the HDC. We've thrown that in. Ask the API for the pixel format index. We need it for this. Found it. We need it for that. Okay. Because at this point they're releasing and destroying the window because they've done the fake one, so they can load up an extension. Okay. That is going through to the API. Yes, it is. I'll come back to release DC and destroy window, I think. Okay. Make sure he hasn't changed too much here. Okay. Set the pixel format. There we go. Oh, it's GDI32 again. So far, I'm semi-happy with this. Not totally. So this is in GDI32. Yeah. Did I say this is the best one I could find? Make sure nothing messes up. Right, what I don't like is that hasn't been placed in. Double click to insert. There you go. Done. This is giving back a bool, so that's either a true or false. So it either does it or it doesn't. Double check. Return value. True. Function fails. False. Okay, yeah. Fair enough. Straightforward return value. So we're just basically just going to call this, aren't we? Yeah. What are you using for format? You're using a cint. Okay. What is the format? It's an int. Index identifies the pixel format to set. The various pixel formats supported by a device context are identified by one-based indexes. It's that there. That's your PF index, isn't it? Gotcha. Yeah. So that's pretty straightforward. Do we use let success or not? Should do, really. But for now I'm not. Okay. So it's that line. We have okay. That goes in there. And you want a PPF8. PPFD. It's just this. Expected value found macro format. Ooh, sugar, don't do that. Oh, that's bad. Okay. I'm going off what the library's telling me rather than what this is telling me. I32, yeah, that's fine. I'm just wondering whether to convert this or not. Into a cint. It's exactly the same as an I32, so will it matter? It's a possible error. Okay. We need some extra Windows styles. Why? Clipping. Okay. All right. As you can see, we haven't exactly used a lot of these, have we? All right. Let's tidy this up. This is what I thought this was being a bit overdone. Just going to take out the ones I'm not using. For now. If we need them, we can put them back in. It's nice to know what they are for future use. But we've only used those 4, so that's fine. WS is down here. I'll just put them in here. Strange, he's gone back to using 8. Huh. Okay. Bit inconsistent. But that's fine. Pop you 2 in. And you're in Create Window. Which is here. So it's DW style, isn't it? Yeah, it is. So we're just adding a couple of flags basically to this. Something to do with overlapping and clipping. Clip, clip, clip. I think that might have something to do with the buffers, but hey ho. Okay. So now we can set the pixel format on our HDC. Yeah. Set pixel format, yeah, I did get it right. Good. Blah, 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 blah. So he's going through something here about choosing a pixel format and getting index. Index is close to what we wanted. We'll come back to that. Okay. So you're doing a lot of work here for checking. Okay. We can print out the PFD. Interesting. Okay. I'm interested. Will this actually give us anything? Or will this crash? Huh. Blah, 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 blah. This is giving back a bool. Okay. Test. No. To do. Test. Please remove this code. And test. I'm just going to print line. See what we get. We're just popping in a PFD, are we? Yeah. I don't see why this would be useful. It doesn't implement standard format display. Really? Uh-huh. Doesn't like that either. Doesn't implement debug. Okay. Hash derived debug. Do I really want to go that far? Not particularly. Is there another way of doing this? It likes its hash derived debug, doesn't it? I don't. Right. Simple. To me, that's a crash at this point. Plus, we've got a device context that we're not dealing with. Not quite sure that I like this idea. Da 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 da. That's because you're returning a result. I've got you. That really is strange. Wait a minute. Alright, using a different function there. Okay. I don't want to make a fake wind class. Okay. So I'm going to skip that. Class name, or you can pass in, yeah. Got you. This is where it starts to lose me. Oh, right, this is for a fake window. Blah, blah, blah. You're formatting that. Okay. An error number. So you're dealing with an error. Ah. Back to the Windows GL. Create context. Right, we want to create an OpenGL context, which is what we set out to do. Ah, now we're hitting OpenGL 32. So this is where we actually get the bits and pieces that we need. I've still got you in dark. Why? What have we got down here that we're not using? Oh yeah, release DC. Okay. We'll come back to you. Right, at this point, we should be able, as we've got a descript and we've got a set, if I've got this right, we've got everything we need now here. Because that's the line we needed. We should be able to create the OpenGL rendering context. Ooh. Do we think this is possible? I'm not sure. I'm not sure. I've already put in this for OpenGL. We are going to need types. So we are looking at, we're going to set this up, I think. Yeah, we'll go with GL underscore types. You can see what I'm doing already. Really, I'm just, we can get rid of all this. I'm basically, excuse me, I'm basically trying to create the OpenGL functionality in exactly the same way that I created the Windows 32 functionality. We'll have another one, we'll call it GL libs, because we're going to need that by the looks of it. Okay, what about structs? Don't see any. Alright, so we can probably start with those two. So if we check our mods, basically we just added them in like this. We're probably going to have to also add an OpenGL file. Probably. To get the context back. I'm thinking a struct is probably the best way to go on this, but don't quote me on that. What we're going to call it? Just call it OpenGL, I guess. Can't, because we've already got OpenGL used. So just call it GL. For now. Okay. I think we're going to be alright with that. Give me some space. Thanks. We're going to need a public access to this. That's going to come from here. How do we do this? We called it Win32. We could call this WGL, but that could be awkward and conflict. Trying to think of a good naming convention for this. Because what I'm looking for is a public struct in here. Anything will do, really. I'll just call it GFX for now. Yeah. Okay. We'll pop in a GFX for graphics. It should be GLFX, shouldn't it, really? Yeah, we'll call it GLFX. Okay. We're doing something similar to this. to operator. So that will go through to GL. I don't like using GL. Okay, so going into GL here. Okay. It could work. And I'm basically wanting to set this up exactly the same way that I set up the Windows 32 API. Exactly the same types of files, exactly the same kind of structure. Okay. I mean, all we took out of this was events. We're going to be adding to that, obviously, now. Yeah, I think we're going to do exactly the same thing. Yeah. Something like that. I'm hesitating because I've never tried this before. And to be quite honest with you, I've got no idea if anything like this could ever work. Okay. Just do that. What are you going to do? Return self? Yeah, return self, isn't it? And that's just going to be GLFX. Is that legal? That's legal. Making legal things. Dear me. It's not. This file is not included in any crates, so Rust Analyzer can't offer IDE services. It's not included in any crates. Ooh. I don't want to use it from here. I think I want to use it from here. Possibly. I'm not sure this is going to be correct. GLFX. Where are you? Come on, tell me where you are. It's going to be super, isn't it? So, super. OpenGL. Ooh. Unresolved import super OpenGL. Could not find OpenGL in the crate root. Huh. do think we have to use it from outside. So we've got the Win32. Oh, I see. Ah. I'm going to have to think on this. It's another awkward bit. Where to use it from? I bet it does need this in, doesn't it? So if we typed in OpenGL, is it not here? Uh-huh. Okay. We would then have to go in for GLFX. It is here. Okay. But you're still not liking it. Did I miss something? No. But I can't access it. For some reason. Okay. It's there. It's not included. There we go. Alright, so we know that works. What I want to try and do is put it in from here though. Super. It'll be OpenGL. Yeah. GLFX. Semicolon. Now it works. Yeah, I can use it from here. One of the things I don't want to be doing is using it from main. So we'll bin that. Reason being is, it's not up to the user of this library to set the OpenGL context. We're going to be doing that internally. You're not liking that, huh? Could not find GL in self. Okay. Interesting. You're right, you can't. So do we have to use it in main? Considering quick fix. 3. It's public re-export instead. Crate with. Oh. I see. So it's allowing us to actually use it through the Win32 API. This is slightly more of a complex setup. Crates go down, supers go up. Crate. Yeah. It's not liking this. Why not? See, it's here. Ah. It's here. It will be where? GL. GLFX. It doesn't like GL. Okay. It's now looking at this, isn't it? And that only goes through there. Oh. Silly me. I haven't got a mod for it. I'm dumb. Okay. Got it. I just put mod GL in here, don't I? Like that. And that will then give me GL. GLFX. Yeah. We'll port you over to GL. Get off me. Get. Put you over to GL. May as well correct those whilst we're here. Okay, main is, yeah. This is now working. That's unused. Which shouldn't break anything. That's now unused. Should I use crate or should I use super? Not sure. Okay. Right, those are the correct colours now. There's no reds. Alright. Interesting. I think we've set that up correctly. Magic. And that's so that we can enter the details required for this lot. So our create is going to be this. That's going to be our implementation. In here. That's going to be this part. For that, we're going to need a public type HGLRC, a handle to the GL rendering context. I see. So that's looking about right. That goes in types. Get rid of the third one, we don't need that. Now handle, it's not going to like that. What is a handle? It's a p-void. What is a p-void? It's that there. I don't want duplication, that's another problem. And I don't think I can link that with that. That's awkward. I mean, we can use it. Alright. Not overly happy with that. On the libs, we're going to have this little lovely bit. Pop you in here for a sec. Do we have the OpenGL 32 lib hanging around somewhere? Possibly. And now we've got this problem, haven't we? HGLRC. Yeah, we've got that. We can just asterisk this. Okay. So we're missing the device context and a boolean. And again, that's just exactly the same thing. Ooh, this is not going to look pretty, is it? And again, that's exactly the same thing. So that's that one done. We just need a bool. Oh, that's an easy one. We can do that. It'll keep itself within. Yeah. Just put that to an asterisk and that'll cover you. Fine. You say you're not being used, but you are. Huh. Alright, we've got them set up in the same way. But I've got a horrible feeling we're going to get duplication like hell here. But most things will go over to GL, won't they? Probably. So we've got create and delete. That sounds fair enough. So this device context thingy is gonna be GL context. I'm just gonna do it that way. Or is it? No, it isn't. What have we just put in the lib? Yes, it is. HGLRC. Bum. Okay. Now we just need to place it in here. Alrighty. So how do we create it? There's your question. Oh God, you're using this thing again. Just need the HDC. Alright. So we just need the HDC. According to that. No, not having that. I'll have an asterisk. Just makes my life easier. So that's all we actually need. ARG1. HDC. No. Let's use a variable. Let's be good. Need to import it. Ugh. There. We'll just turn you into an asterisk for now. Unsafe. Okay. And then all we need to do is make something equal to it. So let H G L R C equal that thing there, please. Yep, that works. And then in here we just put our GL context to HG LRC. Does that work? That can return us a GLFX. Containing a HG, well, a context. has to be kept in the current thread. Okay. So set pixel format. Yeah. Create context. Work with fake context. Clean up the fake stuff. Yeah. Make current. We can do that in here. Create a open. Yep. OpenGL context for the current window and thread. That's important. Okay. Work with the fake context. Alright, so what they're doing now is they are going to call WGL create context with the HDC, which sounds about right. Okay. I'm not quite sure why these are still saying they're unused. Because they've never been read. Never used, yeah. Okay, whatever. We'll come back to you and tidy you up later. Wait a minute, types. We'll see. Oh, nothing's being used, that's why. Duh. Okay. So back here, we'll set the pixel format. We'll set the pixel format, yeah. Now we get our GFX. Okay, so we'll... Okay, we'll try it. Don't know how this is going to work, but we're going to try it. So I'm just going to call it GFX for a minute. Equal... it's going to be... through with the OpenGL. GLFX : create with HDC. Is that correct? Yeah. How do we get there? Just try GLFX. Yeah, there it is. : create with HDC. Did it for me. It seems to be okay with that. Oh god, it's made a hell of a mess here. Yeah, there it is. Okay. It's saying, yes, I can do that. And then we can... that should give me a context. So if I type in gfx dot, we get nothing because that's not public. There it is, glctx, we've got it. Nice. So now we're into this make current. What I don't understand is why I would do that outside of this command. I wouldn't. I'd do that within here. Because you have to make it current for it to activate through the Windows 32 API. And it's in OpenGL 32. I'm not sure about this. We haven't tested any of this at all. It shouldn't matter at this point. But we've got too many errors. Setting this up is going to be a little bit more tricky than I thought. Because of that. It's never red. What that's telling me is I should be making a separate function here. Rust is one of these languages that guides you, and this kind of thing could be awkward. I don't mind never using it here. Do we use it after make current? Yeah. Yeah, okay. Understand. Get proc address. I can do all of this in one function. This is what we're after. This gives us all the procedures for WGL or OpenGL. I'm thinking of splitting these down. Oh my god, you got to do it with the function name. Okay. Function name as pointer. Yeah, that's fine. I'm not doing the extensions. Okay. I think we're going to be okay with that. I'm a little bit worried about how I'm setting up GL. I've got a feeling that that's all we should do. Oh, sorry, my bad. Okay. Why did that not update? Because your mod hasn't been updated. Huh. Okay. Unused import. Oh, it's an import. There you go. Awkward, isn't it? But very doable. Okay. That's better. Now that reads right. I need to think this through properly again, don't I? For usage. Do we need to keep make current? No. Do we need to keep get proc address? Eek, I don't know. We can functionalize that into something slightly different. We have to do it all in the one. The reason being is that we're going to be getting a proc address on a number of things, and that will be a separate function, but it has to come after make current. We have to control the flow. Yeah, so we're going to be doing make the context current. Then we're looking at find the OpenGL command addresses. Yeah. It's something like access. I'm not sure what to put there. I don't know whose proc address you're getting at this point, but we'll see. I'm not doing that bit. Look up the function, call the function, get the info from the string pointer we get back, yeah. Uh-huh. Yeah. Alright, we've got a lot of silly bits to do here. Oh, that's the extension rubbish, isn't it? Okay, that's your extensions. Grab some function pointers. That's what we do want for this part. So what I'm doing is I'm skipping a massive chunk there. Okay. Alright, so there's a few there. Then we store the function pointers. That's why I want to keep it in here so I can store it all here. You've done a struct for window data, and you are keeping hold of the HDC. Interesting. Okay. Then we can... This is why we had to set the pixel format, by the way. So that we can call it back in. Where are you putting this? Okay. Into a vector. And then open the context, yeah. And then you create the context attribute, so it isn't actually done at this point. Okay. Right. We're nearly somewhere. We are nearly somewhere. Okay. Load library. Oh right, so it's a straightforward load library. Get progress, yeah. Free library, load library. Oh. That sounds interesting. What do you load the library into? A module, okay. Fair enough. Okay, we're going to be making a window data struct. Yes, already doing that. Yeah. Yeah, you're doing the public module. We've already beaten you to that. Alright, these are types. Alright. A bit weird way of doing it, but okay. Alright, you're storing those. And then we're onto the clear screen. Okay, by this stage we should be somewhere where we want to be. It's not easy because of the way it's all been handled and done. But it's not the person's fault who's written this. The Win32 API doesn't really handle this too well. So I think we're okay up to this point. Make current. I'm not running it. Yeah, that's okay. Don't mind that. We're going to have to run it, aren't we? God news. It works. It's not crashing. It's not crashing. Dead code. I know it's dead code because we haven't finished. That's interesting. I was expecting it just to crash and burn, and it's not doing so. Okay. I think we've got somewhere with this, and we've actually got possibly OpenGL a context, hopefully. Problem is, it's returning a C void. Pointer. It's a handle. It's just a number. Doesn't mean anything. Don't like handles. But Windows uses handles. Okay. Don't think I can print this out. No, I can't. No, I'm not going to attempt to at this stage. That could be dangerous. Right, okay, I'm happy with that. For our first run at this, I think we've got something we might be able to work with. I was more interested in getting OpenGL set up here than really anything else. Most of this Windows stuff seems to be working okay, which puts us up to creating the actual GLFX. Okay. Alright, I'm going to go with that. I don't think it's right, but... So it's no guarantees at the moment that any of that is correct. All I've done is taken whatever they've said, simplify it down, and then just put in the line of code that I think will get us to our end goal. So this is our first look. At OpenGL. Alrighty. We'll pop that in, shall we? And hope... Yeah, my sound kept going. So that's okay. I think we're going to leave it there, because we're actually pretty close to getting something working. As you can see, this just means it's unused code, it's unfinished code. That's not a bad place to be. Okay. So our first look has got us partially into OpenGL. Just wondering how much further I can take that without, you know, crashing the whole system and probably ruining the stream. Yeah, I'm not certain about it. So in the meantime, I'd like to thank everybody that's popped along, and yeah, I hope some of that was useful if you are looking into using OpenGL. Take care and have fun.